Hello everybody. In this video I will give you all the necessary information that you need for calibration of a 1D model in WSPM. I go into my project and here again I have my structure and I have the water body ester, and here I have my two discharge events, my mean discharge event and my flood discharge event. These are measured values that are defined. So for a mean flow event and a flood discharge event. And for this, in the exercise, we have given water levels. So we have measured water levels at certain gorging stations. So we have, for example, let's see, we have here a gorge, which is the downstream boundary condition, and we have at the profile at the station 3.314, we have gorge B. And for this, we have a measured water level for mean flow discharge and for flood discharge. And our goal is now that our calculated water level is nearly the same than the measured water level. In the video before, I already run the mean flow scenario, so I have results here. Let's look at them, for example, in the table. And we have the station, here we have station and here we have water level. I will go to station number 3314 and here I have a water level of 4.56 meters above sea level. And the measured value from the exercise is 4.5 meters. So we are 6 centimeters higher than the measured. And our goal is now that we want to reduce the water level here by adapting our calibration parameters, and in the 1D case, the only calibration parameter is the roughness of the riverbed and of the roughness of the floodplain. And we will go there. Let's say we go to this profile, I make a right click and say display profile, and here we see we have some default KS values. So these are the gray boxes here, and I can also see it here in the table. So we have a roughness KS value of 0.3 meters on the floodplains, and in the river tube, in the river channel, I have 0.15 meters. This is visualized here. So if I want to look at the water level, or I can look at the calculated water level, so I can click it on here, and here I get all my results. And let's say for our mean flow, I check this, and here I can see now the water level. I will zoom in a little bit, and we see that at mean flow conditions, our water level is of course only within the river tube, and this makes sense. So we use this for calibration purposes, and we use the mean flow event to calibrate the roughnesses, to calibrate the KS values in the river tube. And when we are finished, then we will use the flood event to calibrate the KS values here on the floodplains. So we start changing KS values here. And what we want to achieve is we want to reduce our water level at the gorge B from 4.56 meters to the measured value of 4.5 meters. So which means we have to lower the water level here, and to achieve this we need to reduce the roughness. We need to reduce the KS value. And since we know from the manual that the direction of calculation of WSPM is from downstream to upstream. So it starts here at profile 0 and it goes in upstream direction, which means when we look at our gorge here again, here we want to calibrate, so it makes only sense to change the roughnesses downstream of my gorge, because the direction is from 0 to the last profile, which is station 13.8 anything. So the direction of calculation is from here in this direction. So, and if I change, for example, the roughness at this profile, it has no influence on the water level or at this profile. So it makes only sense to change roughnesses downstream. So to change this profile, and so on. And we want to, or we assume that the gas value is the same at all profiles, so we make no difference, and we say we change it at every profile downstream. There's a special thing that we have a where here, and when we look again into the length section, we see it here. I switch off everything that is not necessary. So they are visualized here. So we have here a where, here a where, and here a where. And when I switch on the water level, this water level, then we see that here we have a sharp drop of more than 1 meter. And so we have a free overfall here, which means that the water level here has no influence on the water level upstream. So it makes only sense to change the values between the where and our gorging station at 3.35, anything from here. So here, from here to here, we want to change the gas values. So from here, I check it and I press Shift until this profile. I mark them. I made right click and I say Tools. And here I can use, or here I have different tools that I can apply. And in our case, I want to change profile properties. Say Next. And I see that my profiles that I marked are already checked. So, and for these profiles, I want to change a property, and the property, I have different properties in my case, so it's already checked. So I want to change the roughness KS value. It's checked, I say Next, and here I can choose where I want to change, and in our case, I want to change in the river channel. I could also check it on the foreland, for example, the floodplain, so now I would change it everywhere when I check all of them. But in the first step, I want to change it only in the river channel, my KS value, and I know it at the beginning. The default value is 0.15, and the calculated water level was too high, so I have to lower it. And I say river channel, and I want to set a constant values in the river channel for all selected profiles of let's say 0.1. And I click on Finish. And to check it, I mark one profile, I say Display Profile, and we see here we have a KS value. You can see it here, a KS value of 0.1. So it is changed at every profile. Here also. So I go back to water level calculation. So now it is the KS value is changed from here to here, and now I want to rerun. And to make sure that I don't forget what I simulated, so I go to my results. Here I have my calculation mean discharge. This is my status quo run that I already made before, and I make a right click on it. I say rename, and I say this is mean flow event default KS. So that I don't want to forget. And now I rerun it with my new settings. I rerun the calculation case, which is here for mean discharge event. Right click, start calculation. Yes, I want to save. Now it runs. Okay, again, we have new results. So this, now we have it here. And I make a right click on it, rename, and say these are mean flow event. And we say KS changed downstream gorge B. So this is what we did. Okay, I will close this. What we have open here. These are some old results that we don't need at the moment, and these also. Okay, so now I have the result from default, and say I'll open the Längsschnitt, and I have my new result. I also open the Längsschnitt, the longitudinal section, and when I switch between them, then I probably can see, or I can hardly see. So here we have a small change. I switch from here to here, very small change that I cannot see very good. So we have to look at the table, and I open the table for the default KS value, and I open another table for the adapted KS values. Open. Okay, now it's open, and we have our gauge at kilometer 3.314, and before we calculated 4.56 meters above sea level, and now I go to the new run with the adapted KS values, and we have a water level of 4.54 meters. So we reduced it by 2 centimeters, the water level, by adapting our KS value. So since this is not enough, so we have to achieve 4.50 meters above sea level, so we have to redo it again and to reduce the KS value even more. Okay, and this is the way it goes. When I achieved, or when the water level fits at this profile here, at this gauge B, we have also a measured water level at gauge C. So, and we can use the measured water level to calibrate the KS values within this section here. So this section can also be calibrated, or the KS value can be adapted, and we do it in the same way than we did before. If we want to change KS values, I mark them here, right-click, Tools, go to Change Profile Properties. Next, we see that the profiles are checked, and I go Next and say KS value, and here I can also change it. And then again, I have to compare it. So if everything is finished for the mean flow event, then I will choose the flood event to change KS values, or to calibrate the KS values on the flood planes. Then it's again, first I need results for the flood discharge. Right-click, Start Calculation. So first I run it for the actual status. So finished. And here I have my flood discharge event. I go to it and I open, let's say, the table, and we have our gauge is at 9.6 at this profile, and here we have a calculated water level of 9.24 meters above sea level, and what we need is 9.21 meters, which is the given value, or which is the measured value at this profile. So we are 3 centimeters away in this case, which means we have to reduce the KS values, but only on the forelens and not in the river tube, because we assume the river tube to be calibrated at what we did at the mean flow event. So now we only want to adapt KS values on the floodplains. So I will close everything here that we don't need. And when we want to change KS values on the floodplains, I mark them, right-click, Tools, and here it is, Change Profile Properties, Next, roughness is correct. And here now I want to change the KS value everywhere, but not in the river channel. So I uncheck this and I check all the rest. And here now I can adapt my KS value however I want, and it is let's say it's 0. The default value is 0.3, and I want to reduce it, let's say 0.25 meters. Finish, and I can check this by display profile, and I see now here we have 0.25 meters and on the floodplains. And now I run run my model and compare again the measured and the calculated water level. And I do it until I achieve at every gorging station I have a maximum difference of, let's say, 1 or 2 centimeters. Then it's a well-calibrated model. Okay, so then I wish you good luck for calibration, and we see you in the next video.